All right, we're going to be solving systems by substitution. This portion we're going to be doing in class, so we're not going to talk about that right now. Our alternative method from the graphing method was the substitution method, so that's what we're going to be doing. And we're going to go through all those individual steps. So when solving, there are several steps that we need to make sure that we do for substitution. The first thing we're going to do is we're going to solve one of the equations for y equals if necessary. Sometimes that's already done for you, and if it is, you don't have to redo that. After we solve, we're going to substitute the value of y in the second equation. After we have substituted in, then we're going to solve the new equation to find x. After we solve, we're then going to substitute the value of x in either of the original equations to find y. And again, that's in either of the original equations. Once we've done that, we're going to check our answer by graphing or plugging in values. This question right here goes with our original stuff, which we're doing in class, so we're not going to worry about that right now. We're going to go ahead and get into solving. So what we can see is right here, one of the equations is already solved for y. So we're going to plug this portion in to our y value because it says y equals. So when I rewrite this, it's going to say 5x plus, and then I'm going to substitute in 2x minus 1, and that's going to equal 34. So you can see that I just subbed in exactly what we're going to do. Now we're going to solve for x, and we're going to combine like terms first. So 5x plus 2x is 7x minus 1, and that's going to equal 34. Then I'm going to do inverse operations by moving the constant. So I'm going to add 1 to both sides, which gives me a 0 pair. And I'm left with 7x is equal to 35. My last step is to do the inverse of multiplication, which is to divide by 7 on both sides. And I'm left with x is equal to 5. Now that I've gotten the x value is 5, I'm going to go back to my original equation to figure out y. So I'm going to personally stick with this one right here just because it's the simplest. Y equals 2x minus 1. We're going to substitute in that 5, so y equals 2 times 5 minus 1. Then y equals 2 times 5 is 10 minus 1, and y equals 9. That means that when I plug into the xy value right here, my x is 5 and my y is 9. So now I've solved where the points would cross. All right, going to the next one. I can see that one of them is already solved for y, so that's what I'm going to plug in to the y value right here. When I start solving, I have negative x plus 3y equals 28. That's negative x plus 3 times my y value, and my y value is 6x minus 2, close the parentheses, and that's going to equal 28. I then have to go back to all the stuff that I've learned, and I need to distribute that 3 in, which then leaves me with negative x plus 18x minus 6 equals 28. Negative x plus 18x is 17x minus 6 to equal 28. I then need to continue by drawing my line down the equal sign and do inverse operations. So I'm going to add 6 to both sides, which leaves me with a 0 pair, and I have 17x is equal to 34. I then have to divide by 17, and x is equal to 2. Now that I know that my x is 2, I'm going to plug it back in, and I'm personally going to choose this equation again because I'm trying to find y. So y equals 6x minus 2. Y equals 6 times 2 minus 2. Y equals 12 minus 2, and y is equal to 10. So when I plug in my x, y values into the coordinates that I'm going to have, I get 2, 10. Again, if they came out easier to solve, we would also be able to do this with graphing, but This is an alternative method, and it usually works best when one of the equations is solved for y. All right, so let's continue. We can see now that in this first one, I'm not solved for y on either one, but we're going to go ahead and solve for y on the second one. I'm going to divide by 3, divide by 3, divide by 3. I'm doing this because this is the easier option. So then I'm left with y equals 3x minus 4. I'm going to now plug this into the y value right here. So I would have 3x minus 3x minus 4, and I like to keep mine in parentheses, and that is equal to 4. One of the big reasons I like to put my point in parentheses is because this reminds me to distribute that 1. That's a negative because there's an invisible 1 right there, and I'm left with 3x minus 3x plus 4 is equal to 4. If you distribute in, it will get you that correct answer. Now I have 3x minus 3x is 0x, so we don't need to write that down, and I'm left with 4 equals 4. When they are equal on both sides, that lets us know that we have infinite solutions. All right, on this next one, you can see that we're going to have to solve for y. So it is your choice as to which one. I'm going to go ahead and do the bottom one solved for y. So when I do that, I would subtract 2x from both sides, which gives me a 0 pair. I'm left with negative 3y is equal to negative 2x minus 27. I then divide by negative 3, divide by negative 3, divide by negative 3. Y is equal to a positive 2/3 x plus 9. I don't really like the fact that it has a fraction in it, but I do look at my other potential equation and I can see that I'm probably going to have a fraction with that one. So that means that I'm going to go ahead and stick with this one. I'm going to plug this in to the y value right here. So that would be negative 4x plus, and I'm going to have to erase some of my work so I have space. That was 2/3 x plus 9. So I did have to erase that work, so then I'm going to plug this in again. And I now have 3 times 2/3 x plus 9. Notice again I'm putting it in parentheses, and that's going to equal 30. I'm going to start by distributing, so negative 4x plus 2x plus 27 is equal to 30. And then I'm going to combine like terms and get negative 2x plus 27 is equal to 30. I'm going to subtract 27 from both sides, and I get a negative 2x is equal to 3. I divide by negative 2 and divide by negative 2, and x is equal to a negative 3 over 2. So now that I have my x value, I'm going to plug that in to one of the two equations. It doesn't matter which one. I'm going to choose to do this one right here. So that's going to be 2 times, in parentheses, a negative 3 over 2, because that's my x, minus 3y is equal to a negative 27. I'm going to multiply, and I get a negative 3 minus 3y is equal to a negative 27. I add 3 to both sides, and once I've done that, I get negative 3y is equal to negative 24. I divide by a negative 3, divide by negative 3, and I'm left with y is equal to a positive 8. And then when I write it as my x and y that I need to write, then I have my x as negative 3 over 2 and my y as an 8. And that's my final answer. All right, now in this next one, I can see that the x is already solved. So in this case, I'm going to go ahead and plug this in to the x value. So I would have -2 times, and plug that in, 5 over 2y, because what I'm doing is I'm solving for y this time, minus 3 is then added to 5y, which equals 22. I'm going to distribute in, so -2 times 5 over 2y is going to give me a -5y. -2 times a -3 is going to give me a +6 plus 5y is equal to 22. I then am going to combine like terms, and -5y plus 5y is going to give me a 0y plus 6 equals 22. I see that I have 6 equals 22, and they are not equal to each other, so that means that there is no solution here. All right, let's keep going. So we have Fish and Fins sells clownfish and angelfish. The clownfish cost $1.50 each, and the angelfish cost $2. At the end of the day, Fish and Fins sold a total of 156 fish and made $260. Let X represent the number of clownfish, so X is the clownfish, and Y represent the number of angelfish sold. Find the number of each fish that was sold in Fish and Fins that day. The systems below represents the solution, the situation. So I'm going to use one of these two to solve for y. I'm going to solve for y right here. So I know that when I do this, x plus y is equal to 156. I could subtract x from both sides, and I'm left with y is equal to a -x plus 156. I now can plug that in to the y right there. So when I rewrite this, I get 1.5x plus 2 times -x plus 156, close of parentheses, is equal to 260. I then am going to distribute in, and I get 1.5x plus, which turns into a negative there because I'm multiplying, so that would be minus 2x plus 156 times 2 is 312, and that equals 260. I then am going to do 1.5x minus 2x, which is going to give me a -0.5x plus 312 is equal to 260. I then am going to subtract 312 from both sides, and I get -0.5x is equal to -52, and then I'm going to divide by a -0.5, divide by -0.5, so I know I'm going to get a positive number here, and I'm left with x is equal to 104. I now can take that and plug it back in, and I'm going to choose to use this equation, which is the original, so that would give me 104, because that's my x, plus y is equal to 156. I'm going to subtract 104 from both sides, and I'm left with y is equal to 52. So then when I write my answer, yes, my x is 104 and my y is 52, but 104, which was my x value, represented the clownfish, so this is the clown, and this would be the angelfish. So there are 104 clownfish and 52 angelfish. All right, let's continue. We're going to use the systems shown on the graph to answer A through C. So first we're going to write the systems of equations. So what I can see here is that this point right here is where it crosses. That is my B, and my B is the point 0, 3, or a +3. And then I have to find my slope, and I can see that here's a perfect point, and here's a perfect point, which would give me down 1 and to the right 2. So my slope is a -1/2. That would be y equals, and I'm writing it as slope-intercept form, y equals mx plus b. So y equals a -1/2 x plus 3. Then I can see in my other equation, it's crossing right here at the point 0, -6, so my b is a -6. My slope, there's two perfect points. I can see I go up 1 into the right 2, so my slope is a positive 1/2. That would give me y equals a 1/2 x minus 6. I now have my systems because it's written. We're going to use the substitution method to solve the solutions. So I'm going to choose to plug in the blue. So I'm going to write down y equals that 1/2. I'm going to plug in the x right here, minus 6. That would mean that since I can't see it on the graph, that I'm plugging it in to find my points. That's a negative 1/2 nope, I made a mistake. Go back. Since I have y, I have to plug it in here or here. So I'm plugged in for the wrong thing originally, but now I'm going to rewrite it so it's 1/2 x minus 6, which is the red, is equal to, because that is y, a negative 1/2 x plus 3. Now I can solve for my x value. So what I'm going to do is I'm going to add a 1/2 to both sides, which gives me a 0 pair. I'm also going to go ahead and add 6 to both sides because I have to have a 0 pair on both sides. That gives me a 0 pair. I'm left with a 1/2 plus a 1/2 is 1 whole x is equal to 3 plus 6 is 9. And so x is equal to 9. Now I can plug that into the x value, and I'm going to choose to plug it into this one right here. So that's going to be y is equal to 1/2 times 9 minus 6. And then y is equal to 1/2 of 9, which is going to be 4.5 minus 6. And I get, when I solve that, y is equal to a negative 1.5 or a negative 3/2. So my coordinate point that I get on this one is going to be my x value, that is a 9, and my y value I'll write as a fraction, negative 3/2. So overall, when is there an advantage to use the substitution method? And that's going to be when we don't see the lines intersect or when one of the equations is solved for y. So we now have an idea of graphing, and we now have an idea of substitution. And there's one more method to solving, and that's going to be elimination, and that's what we do next. If you have any questions, please let me know.